In this video we will be exploring nanotechnology in concrete material. I am sure that a lot of us have heard the term of nanotechnology, but what exactly is it? Nanotechnology is the understanding and controlling of materials at the nanoscale, approximately 1 to 100 nanometers. The existence of nanoscale particles is not a new concept. About a decade ago there was an explosion in nanotech-based materials, leading to developments in areas such as polymers, plastic, car manufacturing and medicine. Nowadays, developments of materials based on nanotechnology, particularly concrete developments, have started to appear in civil engineering constructions. According to studies, nano-concrete offers greater strength and durability. Moreover, it improves the reinforcement's ability to resist corrosion. Nano-concrete can therefore lengthen a structure's lifespan. Because nanomaterials were employed to lower the cement concentration in the concrete mix, which released CO2 that could have an impact on the greenhouse effect, nanomaterials were produced to protect the environment. Nano-titanium dioxide and nanosilica are probably the most reported additives used in modified concrete. Nanomaterials can improve the compressive strength and ductility of the concrete. Carbon nanofibers and carbon nanotubes also have been used to modify strength, modulus and ductility of concrete. Carbon nanofibers can act as bridges across voids and cracks that ensure load transfer in tension. In this figure, the carbon nanofibers are bridging to fix the cracks on this material.
For the justification and benefits, there must be a reason of why we are choosing nanoconcrete as the special concrete to be studied in this assignment. So firstly, why nanoconcrete? So according to Siddiq et al. In 2011, the major application of silica fume is in the construction industry and becomes popularly as property enhancing agent in concrete. So as mentioned by Siddiq et al., the term silica fume is our nanoparticle. So this nanoparticle can increase the property from conventional concrete to another level. So it can be seen from literature that addition of nanoparticles significantly improves the strength and also the durability of concrete. Other than that, nanosilica produces high compressive strength concrete, and it also provides high workability with reduced water cement ratio. So this will be explained in my next slide. So these are the benefits of nanoconcrete. I've categorized into 4 categories. The first one is strength, next one is workability, the third one is reduces, and the last one is others. So in terms of strength, concrete is stronger, lighter and also more durable. So once the lighter is in the game, it will become the lightweight concrete. Next is, it has higher initial and final compressive strength as well as tensile. So initial strength can be considered as the strength measured in 1 day. So as done by previous researcher, for a 1 day strength, it has 15 to 75 megapascal, while for the 28 days, it has 40 to 90 megapascal, and for 120 days, it has 48 to 120 megapascal. So in terms of workability, it appears to have a good workability as well as it reduces water-cement ratio. So in terms of reduces, it reduces superplasticizing utilization. Other than that, it reduces silicosis risk. So what is silicosis? Silicosis is a long-term lung disease caused by inhaling large amounts of crystalline silica dust. So this context can be applied for the workers who will be playing with the nanoparticles while constructing the structure. For others, it has lower cost per building site. So why we are saying that it has a lower cost? This is because nanoparticles could fit up micropores and save cement up to 35 to 45%. Imagine how much cost that we can cut only by saving the cement. So this is the game changer in the construction industry. And lastly, it reduces contamination caused by microsilica solid particles. So that is all for the benefits of nanoconcrete.
Nanotechnology has been advancing at an increasing rate in recent years. Due to the unique uses for nanoparticles, the investigation of nanoparticle effects is of interest, notably in concrete and cement mortar. Many of the studies that are now available have focused on how nanosilica affects the properties of hardened cement base and others. Modification method used is modification to cement and concrete by adding nanomaterials. There are three modifications such as nanoscale non-metallic oxides, nanoscale metallic oxides, and nanoscale carbon materials. Nanosilica is one of the nanoscale non-metallic oxides. Nanosilica is added earlier to cement and concrete after silica fume growth. According to Ghaffari, comparing nanosilica to silica fume, it is found that nanosilica has smaller particle size and higher activity. Nanosilica can also improve mechanical characteristics and durability while reducing workability and hydration heat. For the workability, Qualified studied the workability of self-compacting concrete with nanosilica. They found that the addition of nanosilica made the mixture more cohesive and reduced tendency of bleeding water and segregation. While for the hydration, addition of nanosilica can increase the hydration heat, accelerate the hydration process, and reduce the setting time of cement. For the mechanical properties, nanosilica can enhance the mechanical properties of cement and concrete materials, which can make ultra-high performance concrete. In addition, nanosilica can also improve the early age mechanical properties of fly ash concrete, concrete with ground ceramic powder, concrete with recycled aggregate, and other green concrete. Next is nano-aluminium oxide, which is included under nanoscale metallic oxides. Nanoscale metallic oxides have been shown to improve properties of cement and concrete materials without corrosion and degradation by ions in the environment. The addition of nanoscale metallic oxides to cement and concrete materials can reduce the permeability to ions and increase the strength, thereby improving durability of cement and concrete materials. For the workability, NASA observed that the workability of fresh mixture decreased with the increase of nano-aluminium. In addition, NASA partially replaced cement with nano-aluminium at levels of certain percentage and by weight in concrete. They found that the slump value decreased with the addition of nano-aluminium. According to NASA, the heat release rate values increased and the peak time was delayed as the amount of the nanoparticles in the mixture decreased. Furthermore, compared to the equivalent specimens mixed with water, the specimens mixed with saturated lime water had lower peak time and heat release rate values. For the mechanical properties, Barbuya studied compressive strength of nano-aluminium filled cement paste at early age. They found the nano-aluminium had slight effect on early age compressive strength. Lee observed that addition of nano-aluminium to mortar can significantly improve the elastic modulus. However, the improvement to compressive strength was not obvious. The last one is nanoscale carbon materials, carbon nanotube. Carbon nanotube have a hollowly cylindrical nanostructure which can be visualized as rolling of a graphite sheet according to Sindhu. According to the number of rolled layers of graphite, carbon nanotube can be categorized into single-walled carbon nanotubes and multi-walled carbon nanotubes. The workability of cement and concrete materials is greatly affected by the presence of the carbon nanotube, especially the untreated nanofilaments due to the difficulty in the dispersion of carbon nanotube. The method of covalent and non-covalent modification of carbon nanotube are commonly utilized to improve the workability of cement and concrete materials incorporated with carbon nanotube. For example, Al-Rub found that the addition of treated carbon nanotube produced an increase in workability of cement paste compared with the untreated carbon nanotube due to the increased wettability caused by the functional groups. For the mechanical properties, since early investigation showed that carbon nanotube had strong effect on the hydration process and hardness of cement, a great deal of research has been done to ascertain mechanical properties of carbon nanotube filled cementitious composites such as strength, deformation, and toughness.
Next is discussion. Nanomaterial may easily refine the smaller gap in between the cement hydrated particle. It is fit between pores to make the concrete denser and to make the project to be expected more performance and also for the durability to improve. Nano, also known as ultra-filler. Ultra-filler is a structure pack that means there are no void between aggregate and also the cement particle. For the next point, calcium silicate hydrate that is in the form of gel with nanostructure represent more than 70% of the hydration product of cement-based material. The substance essential to increase the hardening paste strength. As for the last point, various nanomaterial into concrete mix will decrease the settling time. For conclusion, nanomaterial is for energy and effort conservation, particularly in the building industry. Nano concrete has many exceptional features that cannot be achieved by normal standard concrete mix. Nano concrete have many benefits, that is, can provide great strength and durability, self-cleaning qualities, prevent after curing crack, promote corrosion resistance, and also can save energy. All of these factors can combine to make the nano concrete a new choice material for all type of construction. So from us for the project titled Nano Concrete. Thank you for watching.